Do you want to know the secret to immortality? Because here it is. Oh, am I upside down to you? Because to me, you're the one who's upside down. But your observation is not wrong, as it all depends on your perspective, or should I say, your frame of reference. Trust me, this is very important. It can change your life span.
Essentially, a frame of reference is a set of arbitrary axes which are used to describe an object's motion and position relative to another object. Thanks to Newton, it was pretty straightforward to work out the time it takes to travel a certain distance if you're travelling at a certain velocity. But then another great scientist, Albert Einstein, threw a new idea into the mix: special relativity.
This theory seems simple, with only two postulates. The first is that the laws of physics are the same in all inertial frames of reference, and thus the second is that the speed of light is always equal to 3 times 10 to the power of 8 meters per second, or c. Easy. Ready to ace my exam. Wrong. We're not considering the consequences of motion being relative.
If motion is relative, then space and time are relative to each frame of reference. The Lorentz factor is used to calculate this degree of time dilation of an object moving relative to an observer. From this viewpoint, 1 second of this particle's time is equal to 1 second of my time. However, as the particle approaches the speed of light, 1 second of my time now equals 1.5 seconds of the particle's time. This is the moving clocks run slow notion you may have heard about.
Let's break it down, quite literally, as we're going to discuss the decay of muons.
Muons only have an average lifespan of 2.2 microseconds and travel at a velocity near the speed of light. Back in 1962, the number of muons recorded to reach the point of Mount Washington was 536 muons per hour. After the muon passes this point, from our frame of reference, we think that it has 1,910 meters, or 6.4 microseconds left to go before it hits the bottom. There should only be 27 muons present at the sea level, as the rest would have decayed. Yeah, nah. The number you're going to record is 409 muons per hour. If we start a watch as soon as the muon passes the mountain, and stop it as it passes the bottom counter, we record it as taking 23 microseconds. But we know that this must be the dilated time, as the proper timer will be from the muon's perspective, which will see the Earth moving towards it. So we plug all our known variables into the formula and find that from the muon's perspective, it only took 2.2 microseconds to reach the bottom, and therefore distance contracted to be 183 meters long. This is why the muon reached the bottom without decaying.
The muons also teach us that no matter what is happening in the world, we can change our perspective, which has a big difference on the outcome of our lives.